guys, this video is on solving linear equations. The first thing that we're going to talk about are the different types of equations that you may encounter as you are working through some of your problems. The first type is a conditional equation. Now, the conditional equations are what we typically think about happening when we think about solving an equation. That is where you get a finite number of solutions. And then you can also get an identity, which is where you get an infinite number of solutions. Or sometimes we say that the solution is all real numbers. And then you may also get an inconsistent system, or an inconsistent equation, sorry, which is where you have no solution, okay? All right, so we're gonna solve just some simple linear equations first. You have some that are even a little simpler than this example that I've got down here. What you wanna do when you're solving a linear equation is you wanna simplify the two sides of the equation first. You may have to use the distributive property, you may have to combine like terms, and then once you have the two sides simplified, where maybe you have a variable term and a constant on each side, then you want to solve for x or y or whatever your variable happens to be. So what we're going to do here is we're going to go ahead and we will distribute the 6 here, and we'll distribute this negative 11 here. Okay, we'll start with the distributive property. I'm just going to write this down below where it says submit question. So if I distribute 6, I get 6x plus 12. And then we have that plus 4 that's in the equation equals negative 11x plus 77 minus 1. Okay? And now once we've used the distributive property, we can combine like terms. We have two constants here and we have two constants here. So let's put those two together. 6x is plus 16 is equal to negative 11x plus 76. Okay, and once you get one variable and one constant on each side, what you want to do is move your variables to one side. I will probably take this and add it to both sides, and then move your constants, which is when we'll take this and subtract it from both sides. So if I add 11x to both sides, that's going to give me 17x plus 16 is equal to, and now I don't have an x on this side anymore because I've added it and moved it to the other side. So that equals 76. Now subtract 16. So 17x is equal to 76 minus 16 will give us 60. So x is equal to 60 divided by 17. That won't reduce. So that is our final answer for this particular problem. Now, one thing I want you to notice is that there is an x equals already there. So we won't have to put the x equals in. There are a couple problems on down in this homework assignment that don't have an x out in front, but the way they're set up, and it's actually number 8 and number 9, the way that those are set up, we don't have to put an x in there either. We'll just put the number in those as well, even though they don't have the x equals out in front of them. Okay, so this is number 7. So on 7, okay, so number 7, we're going to type in 60 over 17. Uh-oh. Okay, I'll come back and submit that in a minute. All right. Now let's take a look at the problems where we have fractions in the, sorry, I accidentally hit the wrong button there, where we have fractions in our equations. Okay, guys, sorry about that. I think maybe I've got it fixed now where it'll submit. Yeah, there we go. Okay. All right, so the next thing that we're going to look at is solving rational equations. Now, these are equations that have fractions in them. The ones that we have in this section all turn into linear equations once we've gotten rid of the fractions. You can have rational equations that turn into quadratics also, and even different equations beyond that, but we won't be looking at those here, okay? So the three steps that you're going to take, you're first going to find the least common denominator of the equation. Then you're going to multiply each term by the LCD, and that tends to be where people kind of get messed up because it's a little bit cluttered when you do that, and it confuses people sometimes. So you want to go through that step very slowly so that you can tell what you're doing. Then at the end, once we've gotten rid of the fractions, we will solve the equation that's left. So let's just jump in and take a look at this one. All right, so this equation is 1/4 times x plus 1/2 equals 3. So if we look down through there, we can see that, and now my iPad pencil's not wanting to, there we go. Had to dock it, sorry. We can see that our least common denominator would be 2, okay? So our LCD is going to be 2. I'm sorry, our least common denominator would be 4. I'm thinking factor and not multiple. So 4 is our LCD. We'll multiply every single term by 4, and that will make us able to cancel the two fractions that we have. We don't have any x's in our denominator, so we don't have to be concerned about finding an x that would make a denominator equal to 0. We will worry about that when we get to the equations where we have x's in the denominators. We'll have to add a step in where we just check to be sure that our solutions are not going to make our denominators equal to 0, okay? All right, so if the LCD is 4, we're going to multiply every term by that LCD. All right, so the way I'm going to do it right here is I'm going to put that in red and everything else in the equation in black, just so you can kind of see where I have done the multiplication, where I've inserted the LCD. And again, it has to be done everywhere. You can't just do it with the fractions. You have to do it with all of the terms. Okay, so the stuff in black is the original equation. The red there is our LCD that I'm multiplying times each term. So the next thing we're going to do is just look at this piece by piece. Okay, don't try to tackle the whole thing at once. Take in each term one at a time. So if I multiply 1/4 times 4 over 1, the 4's will cancel, right? Those will both cancel, and that's going to leave me with an x. So see, we lose our fraction in that term. Then move into the next term, 4 and the 2, we can reduce that. 2 goes into both of those, so this will become a 1, and this will be 2. So we'll have a 2 left behind there. So you've got 2 over 1 times 1 over 1. That's just a 2. And then the last one, there's no fraction to cancel anything with, and so we just multiply that out. All right. And now when we solve, we're subtracting 2 from both sides, and we get 10. So our answer to that one is 10. That's question 9. So I'm going to go ahead and pop over here and put that in. Notice that it says if you have to, you can enter your answer as an improper fraction, but not as a mixed number, and don't enter a decimal, okay? So be sure you watch out for those warnings. And again, like I said, 9 and 10, or not 9 and 10, but 8 and 9 both don't have the x equals out in front of the box, but you don't need it, okay? It's not requiring that we put that in. It is in front of everything else though, so you don't have to worry about there being one where you do have to type x equals in. Please don't double type it. Don't put it in there after it's already in there someplace else. All right, let's look at another one. I've got 3 of these that I want us to look at. So plenty of examples kind of messed that up. Hang on one second. Let me get this zoomed out a little bit so y'all can see it a little bit better. Now, in this particular case, we can take a little bit different method here. Instead of finding the least common denominator and multiplying everything by that, because I only have two fractions, one on either side of the equal sign, we can treat this like we would treat a proportion, and we can actually cross multiply to solve this, okay? So that's what we're gonna do. But before I do the cross multiplication, you know, I talked about the fact that we don't want the x that we find to make any one of the denominators equal to 0. We call the numbers that make the denominators equal to 0 excluded values. So we're going to look for those first before we do anything else, okay? And the way you do that's really easy. You just take each denominator and set each denominator either equal to or not equal to 0. I like to use not equal to because it kind of drives the point home that I don't want x to be this value. And if it comes out to be this value at the end as the answer, then we have a problem, okay? It's not a mistake, it's just we can't have that as an answer, so your answer would be no solution if you wind up getting those. We have -5 and 5 for those two excluded values, all right? Now, like I said, what we can do here, since there are only two terms, is we can cross multiply. If you have two terms, but they're on the same side of the equal sign, you can move one over and do this there as well. You could work this the other way too. It works fine by getting a least common denominator and multiplying, but this shortens your load. It actually combines the first two steps, doing it the long way. So if we cross multiply, we'll wind up with -3 times x minus 5 is equal to -4 times x plus 5. Be sure you get those right. Distribute both sides. Now we don't have any more fractions, so what we're doing at this point is just solving for x in the little linear equation that's left. All right, so we'll move our x's together. I'm going to add 4x to both sides. That's going to give me a positive x. And then we'll subtract 15 from both sides, and that will give us -35. Okay, then you go back up and you check. That is not an excluded value. Those were 5 and -5, so we're good there. We don't have to worry about that. So that is our answer, okay? And this was number 10. So let's scoot up here. -35. Okay. All right, I've got this one more to try that's a little bit more complex than these other two have been. Just want to be sure I show y'all a full range of problems so that when you get ready to work on them that you'll be a little bit more comfortable with them. Okay, so for this one, we are going to need to find a least common denominator. This one's a little bit tricky, and you do have a couple like this. So I wanted to be sure that I did this one so that you could see what needed to be done. When you are finding a least common denominator on a problem where you have binomials or even trinomials, polynomials, we'll say, in the denominator of your fractions, you need to factor. Now, we haven't talked about factoring quadratics. This is not a quadratic anyway. The only factoring here that you have to do is you have to factor out a greatest common factor, okay? 3x plus 3 does have a greatest common factor of 3. So we can take that out, okay? And now you can see that we do have a factor, x plus 1, that shows up in two different denominators. When you're writing the least common denominator for terms that are not just constants, terms that have x's in them, then what you have to do is take one of every different factor and multiply them together for your least common denominator. One of every different factor raised to their highest power, okay, if you want the full gamut there. And so let's write this out according to factors first, and then we'll put it together and make it a little cleaner. I do have two numerical factors. I've got a 2 and I have a 3. And then we have this x plus 1, okay? So that's going to be our least common denominator. I'm going to clean that up and just make it 6 times x plus 1. Don't distribute any farther, because remember, we're trying to cancel to clear the denominators. And if you distribute over your binomials that you have in your least common denominator, you are going to wind up having to refactor them to be able to cancel. You don't want to do that. That's too much trouble. So let's do this like we did that other one. I'm going to put the LCD in red so that it kind of highlights it. And then we'll put everything else in black. Our first term was 7 over x plus 1. And we had a minus. And I've got 6 times x plus 1 over 1 times 1 over 2. And then 6 times x plus 1 over 1 times 4 over 3 times x plus 1. The idea is that the LCD will have all of the factors of all the denominators, and so we'll always be able to cancel everything, okay? And again, just take them one at a time. There's no need to get in a hurry with this. If we're just looking at one piece at a time and thinking about what will cancel. In our first term, the x plus 1s will cancel, and that leaves you with 6 over 1 times 7 over 1, so we multiply that together and get 42. In the second one, the 6 and the 2 will cancel. That will leave you a 3 up here. Now, something else I want you to notice, there's a negative on this term, there's a minus on this term, and so you can distribute that as you write it down, but I'm going to take a second and do that in a second step, okay? So what I have is negative 3 times x plus 1. Now when we distribute that, we'll distribute that whole negative 3. You don't want to not do that because that'll mess your signs up. And then in this last one, the x plus 1s cancel. The 6 and the 3 cancel, leaving you with a 2 here. So we're going to have 2 times 4, that's going to be 8. Okay, be sure you run through that really slowly. You do have 2 of these that are very similar to this. In fact, I think the 3x plus 3 denominator is the same for both of those too. So if you'll use this as your guide, you should be able to get through those really easily. So I've got 42 minus 3x minus 3 is equal to 8. Combine like terms, so I've got negative 3x, and this is going to be plus 39 equals 8. So negative 3x is equal to 31. Oh, I'm sorry, negative 31. X is equal to 31 over 3. Okay, and we didn't talk about this earlier. We didn't do excluded values this time like I did on the last one. So let's pop back up here and get that done, because we do need to compare. Pretty sure that's not going to be an excluded value just by looking at it, but let's be sure. So excluded values, x plus 1 is not equal to 0. So x is not equal to negative 1. And you're actually going to get that same thing by setting 3x plus 3 equal to 0. You get 3x is equal to negative 3. And if you divide both sides by 3, you get negative 1. Let me make those not equal to's to match the other one. So x should not be negative 1, and it actually turns out that it's not. It's 31 over 3. If you do get one where you get no solution, I think D and E works for that. But you may not run into one that actually gives you no solution. I'm trying to find the right one here. There it is right there. See, you'll notice the options that we have here are limited. You know, when we compare them to the options that we've had in the other assignments, you don't have a square root in here or anything, but of course you don't need one. You know, we need the fractions, we need the does not exist. So we've got sort of our more limited palette. All right, and this was 31 over 3. Again, like I said, I was touching all the way over to the side and it was still popping in the box. So watch that real careful. Make sure when you click, you are completely out of the box before you submit it. Okay, so that is the lecture video for this section. You can watch the videos that are contained in the problems for a little extra help. Be sure you come back and take a look at this when you get ready to do the problems that have the denominators, especially the two problems that have this set of denominators, because you'll kind of need this as a backdrop on those to get those done.